Hello and Assalamualaikum everyone. We are from 3A7 and this video will be sharing on a water reticulation design for subject hydraulics. So, this is our proposed development layout covering parcel A and location of parcel M and parcel N to be developed in a later stage. The supply line from the reservoir are separated from parcel M and parcel N. Focusing on parcel A, the water supply will be flowing through 8 5-story block through administration building cafeteria and admin or cafeteria. So, this is the pipe level layout and the water will flow through the block from the reservoir tank. This layout shows the pipeline from each point of the pipe network. There are 2 loops and the water demand will be flowing in clockwise direction, both loop 1 and loop 2. Moving on to pipe material selection, pipe materials and quality should give a service life of 50 to 100 years. Also, it is non-toxic, non-taste lining materials, curing compounds, sealant and repair materials shall be employed in all water conduits and reservoir. The pipelines will generally be made from spiral welded concrete line multi pipe. The pipe material that has been chosen is ductile iron pipe. This is because it can provide over 100 years of unrelenting and high level performance. Next, it is not subject to weakness or degradation over time, and it is easily recycled itself as it is not made from any toxic materials. For the water demand calculation, the assumption unit for each block for block A until block H is 200 and per unit consumption for each block is 1360. For the both cafeteria is 2270. So the total water demand is 2,180,540 litre per day.
Design flow. In this part, we will determine the design flow, but first need to determine the peak flow and fire flow by using this formula. For fire flow, we need to find the fire risk by finding the class type of the fire risk. So, since our project related to the hostel, so our fire risk is 2,700 litre per minute, which is class B risk. Then, we need to calculate the peak flow and fire flow and compare which one is higher, and it will be the design flow.
So, proceed with the head balance method. The figure shows the draw-off target with a total flow that is equal to 0.070236546 meter cube per second. This is the assumption value of flow magnitude in every pipe, and we use all of this formula to perform the head balance method. The chosen material is mild steel, and the Hazard-Williams roughness coefficient C is equal to 110. This is the first iteration, and the correction value for loop 1 and loop 2 is negative 0.00156 and negative 0.00904 respectively. The correction value for loop 1 and loop 2 in the second iteration is negative 0.000096 and negative 0.00014. For the third iteration, the correction value is 0.0000041 and negative 0.0000036. The correction value for the fourth iteration is the same as in the third iteration.
Now we're moving to residual head. Here, the elevation of water tank is 65 meter. Height of water tank, which is top water level minus with bottom water level, we got it 10 meter. Height of water tank is 30 meter and the available head, H node, is 35 meter. In order to find the residual head, we have 2 methods. First method, we're gonna use this formula. Residual head is equal to elevation level plus with available head, H node, and we minus it with top water level. We can see here, after calculating, we got the residual head 14.5 for every node except for D, which is 14.0. But all this value is greater than 7.6, so we can remark it okay. So next, for the second method, the node elevation level HF and the H is exactly same with the method 1, but the next column is a bit different, whereby we're gonna use the higher supply level HSL, and the next formula is we use elevation level plus with H and we're gonna minus with HSL. After getting all the values, we can remark them as OK.
After complete all the process, we need to design a water tank reservoir. This is the location of the proposed reservoir. To design a water tank reservoir, first we need to calculate the total water supply from reservoir, and then we calculate the total volume daily demand, and the volume provided for the tank is 24,000 meter cube. Based on the calculation, we can conclude that the design is accepted. The proposed material to use for the tank are steel fused with glass, which is this material are best properties of both the strength and the flexibility of steel. That's all from us. Thank you for watching.